All right, so this is what the LightBot looks like for in most cases here we have the 25 IA CRX 25 IA Fanuc collaborative robot, and then you can see the LightWELD here mounted on the torch mount that's provided by IPG. Right now I just have my wire feeder kind of suspended by a ratchet strap here, but a lot of times we'll run the wire kind of mounted on the robot, or maybe a tool balancer is a good idea to use with the wire. Also, you don't have to use the wire. You guys are familiar with light welding, it sounds like. So, you could do wire or fusion welding. We can accommodate both here with the LightBot system. I want to give you an idea of the size of this robot. This is the largest collaborative robot. So I'm going to turn it a little bit and then I'll stand next to it. Let's do it this way. So what the LightBot is it's a collaborative robot. So it's meant to be used in close proximity with people. You can teach this thing by hand. I can move it by hand if I need, drag it into position. You can see the size of it. It's mounted at the table about at my waist level, but I can't even reach the top of it. So this is the big boy. There's also smaller ones available. What is it that you guys make exactly? So I could maybe think about the size of it.
We make metal caskets.
Oh, okay, awesome. Are they steel, stainless, aluminum?
Steel, stainless, copper, bronze.
Oh, awesome. I like welding bronze with the light weld. That's a cool application. I'm not sure if you can see me here, but you can see this one's much smaller. The form factor. It seems like if you're doing a casket, are you doing any lengthwise welds?
We're currently not using it, our unit in production yet. We're just using it as a trial unit, basically.
Okay.
But yeah, the idea would be possibly to laser weld bottoms or even side panels at some point.
Okay. So yeah, I mean, if you're gonna do a long weld, maybe this one would be your optimal sizing. You can also possibly, there's still some talks about, some auxiliary movements on different rails and stuff like that, but I don't think that's out quite yet. But that will be at some point. But yeah, this one has the longest reach, so that might be a good idea. Yeah, as Glenn was saying, you could fit any light weld on this robot. It just requires an update that we can provide. And let's see. Oh yeah, and then you can also take the light weld gun off. You can use it by hand. It only takes about 5 minutes. You can see that like the mount here for the gun, there's one clasp and a door opens and the gun comes out. So that's as easy as that is. And then you can see I have 2 or 3 or maybe 4 on this one, Velcro straps on the robot itself that holds the cabling. And then there's a switch, a little box with a switch that you switch to handheld mode. So in about 5 minutes, you can go back and forth between handheld and robot welding, which is really nice. So the idea of this product was to kind of give some flexibility. Most of the time, like if you have a laser robot system, you're not going to be handheld welding with it, and vice versa. So we wanted to make sure that we retain the use of the system by hand. So you can do anything you can do with it by hand. I was just doing a little testing. I've set up a little demonstration for you. I wasn't sure exactly what you were doing, so I just kind of came up with something a little bit generalized. And I was testing on the stainless. This is 120,000 stainless. Doing a wire weld. Yeah, this is my first go at it. So as you know, the light weld, you have control over, the power, the wobble width, the wobble frequency, all of that. My preferred method is to try to simulate handheld welding as much as possible. So you definitely can make custom settings, make this thing, haul butt, go really fast. But I think the easiest way to get started, especially if you're familiar with handheld laser welding, with the light weld, is to try to do the same thing with the robot. Because you know what you need to do by hand. So just try to tell the robot to do that, and that's the easiest way to start out. So for this application, Again, this material about 1/8 inch. I'm using an XC model light weld with this. Uh, okay, yeah, and then there's a couple different models of the light weld, but I'll show you how it kind of would work on both of them. But with the XC, I chose stainless steel, W for wire. It's 120 thousandths material, but the cross section where these two pieces meet, because I did a little bit of an overlap for the fixture to make it a little easier, is not quite 120 thousandths. So what I did is I went with setting A7 for 80 thousandths penetration, and then I just turned the power up as I saw fit, which I went up about 100 watts. So I'm at A7, 1000 watts. And then I wanted to increase the width of the weld to try to collect the corner a little bit better. So I went plus 50% on the wobble width. I'll kind of move over to the, oh yeah, and then I also set the wire speed on my wire speed to pretty much what it set. So what does it say? A7 65. Yeah, so I have my wire speed and my travel speed set to 65 centimeters a minute. And I'll show you how I do that on the robot controller. Just for your reference, there's the settings that I have on my LightWELD there. Here's my fixture. Wow, that's really bright, isn't it? Anyways, yeah, it's just I'm just using binder clips. And you can see that the fixture has, end stops here and here. So I basically put my plates on, move it over. Repeatability is something that's going to help you out a lot with the robot. The more repeatable your part is, the more repeatable your weld is going to be. So see this one, I turned up the power a little bit, got a little bit of full penetration going on here. That's what I was looking for that I didn't get on that other one I showed you. But yeah, so fixturing can be really helpful. So, if your parts are repeatable, I would definitely try to make a good fixture so you don't have to fiddle with positioning a robot every time you weld it. Okay, so now I'll show, any questions so far, by the way?
No.
Okay. Okay, so let me show you the welding program. So this is a fairly simple weld. Obviously, it's just a straight line. And so the program is also fairly simple. We have our first, we programmed this, this robot by using these icons. So it's kind of like, to me, it feels like the interface of like an Apple, even though this is an Android tablet. You can click an icon, hold it, then it's able to be moved. You can drag it somewhere else. So same here. So if I want to put this icon at the end, or maybe I don't hold it, maybe I just drag it. Yeah, I can move that to the end. It's real easy. And then the way that I get these icons is through this programming menu down here. So these are my history. So this is pretty much all I ever use. I like to keep it dead simple. I don't want to overcomplicate anything. So this is all I use. And there's actually a couple here that I don't use and I just put in there to look at them. This is all of your choices of icons. Many of them don't have to do with welding. They're just preloaded on these robots. These are the ones that have to do with the LightWELD that we've developed here in-house. So ones to, turn on and off the laser, set power, set power's here, set program is here. And then you can create your own presets, just like the LightWELD. If I can make power presets, so I don't have to actually like type in the number. I can just drag up, okay, I want 500 watts here, 1000 watts here, and so on and so on. There's a whole bunch of icons that we've developed. I typically just use set program, laser off confirmation, laser off, and laser on. So as you can see, it's very simple. Motion. So all these ones with arrows are going to be motion. So we have linear motion, joint motion, circular motion, and then the rest I don't use. So, but yeah, you can see the programming is pretty simple. If I wanted to add a point at the end here, I'm going to drag it. And wherever that robot is positioned right now, when I drag that point, is this data. So it records it as I drag it up, it's like, save this data, save this data. So now if I want to move the robot, I'll zoom out here. Say I want to change that position. I want to override it, right? I'm gonna go ahead and move the robot. So I'll jog it. I also want to show you that you can move it by hand, but I'm gonna jog it. So yeah, jogging it in the Y plus direction. X, Y, Z. So I'm going Y plus, that would be X plus and Z plus. So let's say I want to make that position now. I'm going to show you how the data can be altered. Okay. So I'll click on the details of that previous position. Let's choose one of these numbers, Z, 413.396. That's the previous one. I'm going to click touch up, OK, and that 413 changes to 504. So you see I've now, that icon now is recorded this altered position. So say you want to change something, it's as easy as that. You click touch up, OK, and it'll override. If I messed up or I did something, you know what, I want to go back. Just do the undo button, 413.396, redo 504. So it's very, very simple to use. The interface is very easy. As far as controlling the laser, we're going to have set program, A7. I would do my override power and wobble length here typically, but I did it in a different way, which is basically using the LightWELD interface instead. But this is typically all you have to do. A7, click override wobble length. You want to do 50%.
So he's using the same nomenclature he'd use by hand. The same.
Yeah, I'm just looking at this chart and kind of making my setting there. So, and then as far as the laser on goes, you can set your gas pre-flow timer, your power ramp up timer. You can tell it to use the wire feeder. So I'm using wire feeder here. I have a certain wire feeder selected. This one that we have is a Binzel unit. That's what we're using. That's what we use kind of in our little test lab here. So Binzel, 65 centimeters per minute. So it's all pretty much how you would do it by hand. Instead of walking over to your wire feeder and changing your settings, you're just gonna input those settings here, and it's going to make that a reality. So yeah. So any questions about kind of how the programming works? There's obviously a ton more that I can tell you about this, but I think just the basic programming is kind of the important thing to know.
No, I've seen the program before at some of the trade shows, stuff like that. So it's pretty cool.
Okay, awesome. All right, so if you don't mind, I'll just get into doing some welding here. I'll show you that program. Oh, you know what? I think I want to just, yeah, you know what I'll do is I'll make a representative. I'll kind of make this program real quick just to represent like what I did. And then I'm just going to play this other one that I have. But I literally made this program about 20 minutes before we started this this demo. I didn't have my sample parts until this morning. So yeah, I can easily show you kind of the gist of what I have to do here. Okay, so the first thing that I'm going to do is on my LightWELD, I'm going to put a teaching tip. So what you see here, this comes with the robot kit. This is a teaching tip, and it basically tells you where the TCP of the laser is going to hit your material, the tool center point of the laser. So ultimately, you want to teach with a tool center point tool like this. Now, this is meant to for the robot to find TCP. You do a search routine like this, so the robot can locate where that TCP is. I use this when I'm doing fusion welding. What I've done for the robot to get a little bit more accuracy for wire welding is I've kind of set up a simulated wire welding setup. So I have like a nozzle with a collet and a wire that I've soldered into this contact tip that's cut right at the right spot. I use this to teach. In this instance, I didn't because it's a straight line weld. It was very easy. But like when I get into kind of more complex geometries, it helps me to kind of judge my clearance you know, what my wire feed clearance is going to need to be, and all that with something like this. I also have a 3D printed file that I made, and we can provide at request, or I can send you a 3D printed part that basically does the same thing, shows you where the wire's TCP is, and also has a little flag on one end, representing the angle of the wire feeder. But yeah, basically what you want to do is you want to have, you want to teach where the laser and the wire will hit the surface. So what I did is I just moved the robot. Let's go ahead and move it. Once I can reach it, I'll show you how to do it by hand. So yeah, what I did is I came down here, I looked at where the wire hit the laser and the wire interacted. I clipped it right there. That's what I used as my teaching tip. I recorded points as I showed you earlier, basically just moving it and then dragging an icon to record that position. So right now I'm going to put on freehand teach. So I would basically, move it. Say this is my home was over there. This is my approach. So I'll drag an icon, figure out the angle that I want to hit this, adjust it there. Typically, I'll make another point right above the part, and then from that point, I'll go slower so that if there's anything out of alignment, if it crashes, it's going to be less of an impact. So I'll move like super fast through here. Down here, I'll slow it down a lot. Record a point here. I can put it on translation
Can you show them
mode.
that? Can you show them the timeline, what you're doing?
Well, I didn't actually do it. I was just
Okay.
kind of simulating it, but
what you would be doing.
yeah, so maybe zooming in would be a good idea here. So yeah, this point here, right above the surface, would be essentially this point number 3. Point number 4, come on, focus. Point number 4 would be the point at which my weld starts. So that is going to be, oh man, the camera decided to go home. Sorry. Where my weld starts is going to be more like this. Like right where the laser and the wire interact, I'm going to put it essentially touching the material. That's kind of where I want to teach, is at a point where it's actually touching, just like by hand, right? You're going to touch down with your wire, you're going to pull the trigger, and it's going to go. So that's going to be this point. Then right here, I have a wait command or a pause. I typically do about a 2-second pause, or even a 1-second pause would be good. And what I do that for is that at the very beginning of the weld, I want to make sure that the robot or the table, after the robot's motion, I want to just kind of let any vibrations settle before starting the weld. It's not critical, but it's just something that somebody mentioned to me one time, and I said, you know what, that's a good idea, because if the robot's moving around, the table might do something like this. Good idea to put a small pause there. And then it's going to just like by hand, pull trigger 1. If this is all done in software, it's going to pull trigger 1. It's going to feed the wire. Once it sees that it's contacted, it's going to pull trigger 2, and then it's going to move the robot along. So the whole program is just, move the robot, drag an icon, input information, and then you can dry run it, and then you can actually run it. So
can you show them how you lock the axis then to move it to the next position, or the angle there?
Sure.
Yeah.
So yeah, right now I'm in translation mode. So translation mode, now that I found my kind of angle of the gun and all that I want to do this portion of the weld, I can lock that. So I'm going to put on translation mode, enable freehand teach, and you can see I can just kind of pick it up and drag it over here. There's nothing I can do to change that torch angle. Whatever I do, even if I move the robot from over here or right here, the torch angle is going to maintain. So that's really good for linear welds. You can find your start point, just move it over here, and then your angle didn't change. Whereas there's also, so that's translation mode. There's also freehand mode. And that allows me to kind of do whatever I want with the robot arm. There's also rotation mode. So right now it's going to rotate about the TCP. Moved it a little too fast there. You can see I'm kind of wherever I grab it from, it's going to move about that point. So that's rotation mode. Yeah, so yeah, it's real simple. You know, with these systems, typically, you know, we'll give like a training with it, and it's not something that's difficult, especially for people who know how to do light weld already. Because if somebody's new to light weld and the robot, then it's typically more about teaching them the light weld, and then we have to get onto the robot. Whereas if you know the light weld, then the robot's going to be, you know, you already know what information to input in your light weld to make the weld. So, okay, yeah, so I'm going to go ahead and just run this weld. I'm going to do a dry run. Again, I've only welded 2 of these. So I just want to kind of verify that the position is good. I haven't verified that these parts are consistent yet. So I just want to dry run it. And then once I'm confident that it's going to make the weld just fine, I'm going to turn dry run off and go ahead and weld it. Typically I'll kind of design my parts with maybe like some type of feature to where it ensures that it locks in, like a little tiny tab or something. But again, it can all be built into fixturing to make sure it's located good as well. So I'll disable the weld. I'm going to kind of clip my wire here so it doesn't hit the material as I do the dry run. And I'm gonna just go ahead and do the dry run. This is like actual speed of the program here. This weld is 65 centimeters a minute. I've matched my wire speed. It's real easy. It's just like by hand. When you set your wire speed, that's going to be your travel speed. So the wire is going to be feeding in at the same rate that the robot's going that way. Now you can overfeed the wire if you want to build up a little bit more. Yep, looks like it's fine. Okay, so this next one, I'm going to go ahead and put on my welding helmet so I can look at it a little closer. I'm going to click activate weld or weld enable. Make sure I'm at 100% speed. I'm gonna go ahead and run the weld. So the continuity is still being satisfied for the light weld. The wire feeding into the surface is creating continuity at that, you know, molten intersection there, just like as if you were dragging by hand. So, you know, all the safeties are still in place from the light weld. So, you know, if it breaks contact, it will turn off all of that stuff. That's probably not too hot. So yeah, it's just kind of what you expect from a light weld. Any material that you're going to be able to use. It's just the same as handheld. Right. Nice consistent heat input. Narrow heat affected zone.
So I know with the handheld unit, angle of the gun's kind of important. Not only for a good weld, but so you don't damage the lens. How is that?
It's the same. You don't want to be straight down into the surface ever. All laser systems you want to, except for I think cutting's a little different, but all welding laser systems, which have the tendency to have some type of reflection backwards, you want at some type of angle, just a little bit. the handheld recommendation for these to be at like 50 degrees is not only for the reflection, you know, because you don't need that extreme of an angle for reflection. You can be much more straight up and down and still not get a reflection because it'll go the other way. The drag angle is a lot about you know, the ease of drag. If I'm dragging something at this angle, it's pretty smooth. If I'm trying to drag it at this angle, it kind of, you know, does one of these things. It grabs a little easier. So the 50-degree drag angle is a lot for just kind of the handheld use. I typically go a little steeper on this with the robot, maybe like 30, 25 degrees. But yeah, you still don't want to go straight in because you do have a chance of a back reflection.
Yep.
One thing you'll notice is we have the gun inverted here. Just makes sense for cable management, and you know, the laser beam coming out of the middle is the same, you know, this way versus this way. Just sideways, not a good thing, but you know, this way or this way, it's fine. So we just inverted it.
Hey, and Evan, what
Yep.
what more control when you're doing this with the robot, like how you can change power into the corners and things?
Oh yeah,
Uh,
yeah. So by hand, you know, by hand you can't change the power of the welder as you're approaching something, right? Whatever you have set, you're pulling the trigger, it's welding at that power. With the robot, we have a lot better control. Oh, that's cool. Okay. With the robot, we have a lot better control because let's see. For instance, okay, let me show you two of the welds I did. I'll show you the last one I just did and then the one before that. And I'll show you what difference I've done. Okay, see at the end of this weld how it got a bit hot there? That was the very first one I did. See how it burned through there? Not bad. It's all right, but this tells me that the robot sat there for too long while the laser was ramping down. So this one ended up a lot better. We still have nice heat all the way to the end, but you could see that the heat trailed off at the very end and didn't burn through. You know, I could still dial these in some more, get the positioning closer to the edge and all that. But what I did here is this one, I had my laser off. I had the robot go to my end point and then turn the laser off. And that was it. The second one, I had it go to the end point, but not stop there. Or let's see. I didn't go to the actual endpoint. I went about a centimeter before the endpoint and had it continuous. See, it says here CNT, continuous. So it hits this point. It's going, 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 hits that point, keeps going. Let's make this edge of the screen. So start point, laser on, weld. And then instead of going here and turning the laser off, I went here, turned the laser off, but kept it moving. And then that's my actual endpoint that it stops at. So that way it starts the ramp down as it, you know, as it's approaching the end rather than getting to the end and then ramping down the power. So it's just stuff like that that allows you an enhanced level of control over handheld light welding. You can control the timing, the length of the ramp down, you know, the speed of the robot, all that stuff. Whereas by hand, you know, essentially you're supposed to touch the surface, let the wire push you back. When you get to the end, lift off the surface, or there's a couple ways to terminate, but there's something to be desired with the termination of the weld, typically. So the robot gives you an enhanced level of control on all that stuff.
Can you show them how the IPG user interface runs on the tablet too?
Sure. So yeah, the IPG user interface, you know, for us, you know, maybe I don't know if you guys have used it yet, but for us, it's been a absolutely incredible tool because here at Cerro, we do, you know, we've done probably thousands at this point of applications, and some of them are not so simple. And some of them are materials that are not on the list. Some of them are much thinner or thicker than what's on the list. So we need to be able to have a lot greater control over the light weld so that we can make custom settings and stuff like that. for instance, with bronze, it's a very easy material to weld, but you know, you may want to create a custom setting because there isn't settings for it. So yeah, so this is the LightWELD user interface. I'm just going to access it through this drop down menu, and it's within our plugin. See LightBOT here. Click LightWELD user interface, and you have access to this screen. You can see my settings here. On the LightWELD, I have a little bit more control here than typical on the LightWELD. I have gas flow control and control over my ramping up and down of the laser beam, as well as if the wire feeder is enabled or disabled. I can also view all my alarms. So let's say I had an alarm on my LightWELD, it'll tell me, not just ER21 or whatever, it'll tell me exactly what it is. And you can do this, you know, even right now without the robot, you can access these, this user interface. The manual actually tells you how to do this, but it's real handy to have it right here on the tablet. It's all in one device. I can go right here, make a custom setting, then go right back to my weld program and implement it. There's some advanced controls here. Centering of your laser beam. If your laser beam is slightly off center in the nozzle, there's a centering, a wobble offset, so you can adjust that and it'll move the laser beam slightly inside of the gun. You can see here, this is kind of what you need when we do the Cobot integration. We have to add this ability, Cobot enabled. It allows the robot to communicate directly with the LightWELD and set settings and, you know, turn the power on and off, stuff like that. So this is really handy. Again, I don't know if you've used the custom settings, but you go here and you click user, and then you can define an index number. I think you have 20 available to you, or 10 or 20 or something like that. So let's say I want to make setting number 13, click go, adjust my power. I also am not going to be in the custom settings. I'm not going to be doing a plus or minus percentage. I'm going to set the exact value. So if I want my width to be exactly 4.1 millimeters, bam, my laser is going to wobble 4.1 millimeters. If I wanted to wobble at 2 hertz, super slow for some reason, 2 hertz. If I wanted to go 300 hertz, 300 hertz. So you have like a ton of control on this. The settings that you have here enable you to do so much more than what's on this chart. This chart is designed around, you know, new users, getting started without having to know anything about the laser, your typical sheet metal applications, and it works great. Most people probably only use that, but if you ever do something that's a little bit off the wall, this is like priceless right here. So, yeah, we use that a lot for like, typically, honestly, when we use that is when we're trying to get, when the customer needs like, you know, more than a 1/4 inch penetration on the weld or something like that. We need to dial in the settings perfectly to get the optimal laser penetration depth. And also with like super thin materials, I've welded down to 5 thousandths stainless with a LightWELD by hand. So the robot would be even easier because your speeds are consistent. But yeah, it's all using this interface here that's also built in. Any questions about anything or any requests?
Yeah, can you show a fusion type joint?
Sure. Yeah. I probably do the same weld just because I don't have any other fixtures going on, but I'll just do it without the wire. So let me go ahead and I think what I'll do is I'll just kind of leave my setup on the end of the arm since I've already taught this joint and you just want to see it done without wire. I will just cut the wire short. Or no, I'll probably kind of leave the wire. Yeah, I'll basically tell it that there's no wire and then it won't feed any wire. Yeah, sorry I didn't prepare more joint configurations. The robot demos sometimes, you know, you have to pick something and go with it because the programming takes a little while sometimes. So I just click not to use the wire feeder. And then the only other setting I'm going to change is my laser setting. So I'm going to just look at my chart here, go to stainless steel, fusion welding, continuous wave, go to A2. And I think that's going to be good.
Can you show them the tablet, what you just did?
Yeah.
Yeah.
Okay. So all I've done is instead of A7, I put an A2 for fusion welding of the same penetration depth. Still turn my width up to 50% increase. I'm also going to override the power a little bit. No, you know what? Just for a first trial, I'll just run it as it is. I'll determine what I need to do from there. And then on the laser on, I just disabled the wire feeder, enabled fusion lock, which is going to help us with making continuity with the fusion weld. And yeah, everything else can remain the same. The position of the part is the same. Yeah, so all I've done is change the setting on the program, like the front face of the LightWELD, and I've deactivated the wire feeder. Okay, so the last thing to do is clip the wire because I'm not going to need that there surface anymore. And then I can go ahead and run the weld. So here I go. And I get the camera optimized. I think I'll zoom in nice and tight on this one. There we go. All right, so there's the fusion weld.
Cool.
Just like by hand, if you want more penetration or more width, you just adjust the settings.
And generally, you can fusion weld quite a bit faster with this than by hand. Is that right?
Yeah, let me make one that's a lot faster just for fun. I know I need more power on that anyways, so let's
Do you find it's hard to often find the correct travel speed?
no, not really. You know, what I've found after using a LightWELD on a whole lot of applications is that most of your travel speeds are going to be between 50 and 75 centimeters a minute. So a lot of times I'll just kind of choose one and go with it for everything. I almost always go 65. And then I just dial in the rest of my settings. But I'm also like by hand, I'm not the kind of guy who wants to just try to go as fast as I can with my welds. I really, you know, coming from a TIG welding background, I'm very used to you know, being extremely observant of what's happening during my weld and adjusting as I need to go. So with the LightWELD, even though you can go really fast, a lot of times I'll just go kind of a little bit slower than what they recommend. And that just allows me to, I feel like I have a better control over, you know, if I'm if I have a little hiccup, I can correct possibly. It's still bazillion times faster than MIG or TIG welding. So it's, you know, I think slowing down is not that bad by hand. And I just kind of match what I do by hand with the robot, but for sure you can go a lot faster with the robot. But yeah, finding the speeds is not bad. And with the wire, you just match the wire speed to your weld speed. If you want to overfeed the wire a little bit to accomplish more material deposition, you can do that also. You might want to increase your power if you overfeed the wire, but you know, I follow the chart for the most part, and it works good. So this one, I'm gonna make this one a lot more powerful and a lot faster, just for fun. Okay, so let's see. I'll go down to the LightWELD screen here. Oh man, the camera. What is it doing? I think it'll, if I move the camera too far in one direction, it kind of hits an end stop and just goes back to home for some reason. Okay, so I am going to make this motion, that's the laser on, right? So the motion after is going to be the weld. Instead of 65 centimeters a minute, I'm going to make it, I don't know, let's try 100. More than, let's just go 120 or let's do 130. Let's double the speed. 130. Taking risks today. All right, 130 here. On the last little bit of the weld, that's like as the laser's ramping down. And then on the power, I'm obviously going to need more power. I think for this kind of speed, I'm going to need a custom setting actually. That's double faster than what the factory settings are for. So we're going to go user. I'm going to go back to that 113 that we were talking about earlier. And then I'm going to, so I know I'm going to need to set user 13. By weld interface, user 13. That's going to be a continuous wave weld. I want the ramp, it's going to be fast. So I want the ramp up to be only 20 milliseconds. Ramp down to be, let's do 500 milliseconds, maybe a half a second. Disable the wire feeder. I'm using a steel. Power, probably going to need to be max power on here for that speed. The width, maybe when you're going real fast, you kind of don't want to go as wide because you need that weld to be nice and focused in a tight spot. So maybe, I don't know, 1.2 millimeter width. Frequency is going to need to be pretty fast. I'm going to try 100 hertz wobble frequency. Click save. These are all things that, like, as you experiment with this interface, you'll understand a little bit more what each one does. But yeah, for like going way faster, you probably need a custom setting like that. And all right, let's just try it out, see what happens. So all right, so this weld speed should be much, much faster. And we're gonna weld. I think it's welding pretty nice, actually. Could have used less power. Obviously, lots of over penetration down here. Also, my part was not good in my jig, so they were welded kind of like this. You'll see once I show you the part here. Yeah, so that's 130 centimeters a minute. And it's not perfect, but that's my fault.
Okay, I'm gonna put you on the spot. I want a different weld.
Okay. What do you want to see?
What I want, so what we're planning on using as an application for this is it's an overlapping seam joint.
Okay.
So two your pan test panels flat on the table.
No problem.
Sit on top of each other.
Like a lap weld, basically.
Yep, a lap weld. Yep.
Okay. And you're trying to weld at the actual joint, or are you trying to go through one piece into the next? I've seen a couple different forms of lap. Some of them are like going through one. Some of them are like at the seam itself.
Well, welded by hand, we're kind of going at it at an angle, so
Okay.
I don't know
You-
on it.
Are you fusion welding or wire welding?
I would prefer to do fusion if possible. Now we'll be running like 18-20 gauge, not
Oh yeah,
that thick.
yeah, it's a lot thinner. Okay. I don't think I have any thinner metals. I would try to do something a little more representative. I wasn't sure what exactly you guys were doing before, so I just came up with something. Let's see.
But we're doing this on copper, bronze, stainless, mild, all those.
Okay. You have an XR unit, huh?
Yes.
Okay. Okay, I'm just gonna run that piece, but yeah, sure, no problem. I'll do that, a fusion weld. Um, I don't know if you've seen any of the videos we put on YouTube, but we've done all kinds of stuff with this LightBOT system.
Basically what we're doing right there, we're welding a rectangle. So basically down the long edge and across the side, and we're doing a complete rectangle. But I mean, obviously for this, I'm not worried about that, but
it would be cool if you saw this, right? Like going along here and then just right into this guy.
Yep.
Awesome. All right, so in case I have to do another one, in case the first one settings are wrong or something, I'm
you
still
got
gonna
one chance to get it right. That's it.
one chance. All right, I won't I won't even clamp it down then. No, I'm just kidding. I gotta clamp it down. All right. Let me find some clamps over here.
So you've got to clamp it down because you got to make sure that those stay without a gap between them.
If I'm gonna fuse it, yeah, I can't have a gap.
Right. Okay.
With wire, I mean, really the reason I'm gonna clamp them down in the real reason I'm gonna clamp it down in most cases is because if it warps, it'll create a gap, right? Or the part will move, as it's welding, it'll kind of do something else. And plus when I'm teaching it, the last thing I want to do is go through teaching this and then like accidentally bump it, move the parts, and then I gotta do it all over again. So yeah, so that's clamped down. I'm going to just make that might not be the let me see if I can even, that might be a weird position for it because I'm kind of like at the far end of the table. Normally I do stuff like this over there. I'm gonna move the robot, see if I can actually get over to where I need to go with this before I start programming it. So there's like kind of sweet spots for the robot. This is the robot's on that side of the corner of the table, and I'm over here. Certainly it can weld over here, but the angles that I'm at, I need to make sure first before I start programming. Oh, okay, so I gotta take the wire off. The wire is not reaching that far. Okay, so I'll take the wire off. I'm gonna teach with that teaching tip is what I use when I fuse weld. Okay. All right, so I can certainly reach the beginning. Certainly reach there. And it's a let me show you the position of the robot here to get an angle on this joint. So you can see I'm kind of getting to a stretch point here where that's almost at its reach because I have to come back at the part. So I got to get this past the part. Does that make sense? You can see there's a limit right about there. So the part would be a little bit better. This part just a little bit that way. So that's what I'm going to do. Right there. Okay. And I'll just go ahead and teach that because I know I can reach from there at this point. So first things first, I'm going to start with a new program, totally new program. Did I spell Aurora right there? Aurora?
No.
No?
You are.
Sorry, I didn't see the email, so I just guessed. Select program. I'll make this next one correct. So tell me how to spell it.
AURORA.
A-U-R?
Yeah.
O-R-A. Aurora. Oh, that makes sense. I knew it didn't look right. Okay. Aurora. Fusion. Lab. So this is how I'm making a new program. Telling it the name. I can put a comment, describing it. Okay. Bam, blank timeline, right? Okay, so I'm going to start off with the home position. I want to get the robot up and out of the way. So that way, when I need to change the parts out of my fixture, there's not going to be any interference with me and the robot. So I need to kind of move the robot back over that way. Z. So I also like my home position to be a kind of a good starting position for the next weld. So I'm just going to have it pretty much preset at the angle I need for the weld. Hopefully off the table a little bit more. All right, so I'm going to call that my home position. Can easily access these clamps without banging my head into it. So that's good. So first things first, let's record that position. Now I can also make a global home if I want. I can make a global home that I can drag up in any program and it'll go to that position. I'm not going to do that here. My home changes every time I do something pretty much because I'm always doing something different. But I'm just going to drag a point. I'm going to do a joint move as my very first move. The difference between a joint and a linear is that a joint will move every joint of the robot in any way that it has to get the robot from where it was to where you're telling it to go. So the reason I do that at the beginning is if I ever get programmed into a position where the robot's kind of like bound up and it's stuck, it won't just go straight from one to the next. I can always go to that point and move to, and it'll move all its joints in whatever way it needs to get back home. Linear moves will do anything they can, or they will only go in a directly straight line between the 2 points that you've taught. So if you teach a point here and a point here, it's never going to go, it's never going to flip upside down and do all kinds of crazy stuff to get over here. Joint, if it has to flip upside down to get over here, it will. So I put that as my first point at my home position because it'll always get home, even if I, made a boo-boo and twisted it all up weird. So yeah, the only one I really do as a joint typically is the home position. Okay, so home position is recorded. Next. Uh-oh.
Quick question for you.
Yeah.
To move the robot, can you use the teach mode on the arm, or do you have to use the XY controller on the pendant?
No, you can move the robot by hand. It's not my preferred method. I like in my head, I can envision the coordinate systems pretty well. So I think it's really easy to be like, okay, X plus, Y plus, Z plus. But yeah, some people are gonna definitely tend to just grab the robot and move it like that more. It's just kind of personal preference. You can definitely teach it though with just by hand. You still have to go back to the tablet to enter information about like laser on, laser off. But
Right.
as far as the positioning goes, you can do it from here.
Okay. I just knew you could do it with the MIG welding cobots because I've sold several of those. I didn't know if that was an option with your guys's, that was available with the torch mount and everything else or not. So that's what I was asking.
Yeah, so the mount, I have the mount set up right now without the buttons. I wanted to shorten it. I was doing some testing. You know, there's a can like right here. It typically moves the mount down a little bit. I was just doing testing, so I have it shortened, and you can do that as well. It's all adjustable. You know, you can just take 4 screws, or I think 8 screws out, and then reposition where you've mounted it. But the can looks like a soda can right here. Has the 2 buttons on it, and so what you do is you'd actually drag an icon into your timeline that allows you to teach positions from there. You cannot do the laser on position from there because it is designated for arc welding and it doesn't work with the laser. But you can record positions, so you can move it, click a button, move it, click a button, move it, click a button. You just can't do the laser commands basically. And we're working on trying to get that going, but we just haven't gotten that finished yet. I accidentally unplugged this thing when I set it down, so you might have seen it starting back up. I'm not sure how I did it exactly, but somehow I unplugged it. So, I'm back to it already, but I had to sit there and let it. It was good you asked that question because it was going through its process of starting up. Okay, so I got my start position. My next one, I'm gonna move to a position close to the part that I think this is a good view to kind of go for the rest of the way. You can see my programming and the part. I'm gonna move my next position above the part, basically in a Z minus direction or Z plus direction from where I want to start the weld and above any clamps. So I can do my slow speed. You know, it's not gonna hit anything on the way down, and then I can go slow into the part like this. So my next position, I'll do it by hand just so you can see that. What I'm gonna do, I'm gonna kind of move it over here. Right, maybe something like this. And then from there, I'll go a little slower. So let's see if I can show you that. All right. So chord linear move. Okay. Now I'm going to get closer. I think the reason I got in the habit of doing jog is when you get really close and you want to position it accurately, you're going to need to do the jog to do like the extreme accuracy because you can move it within like 1/10 of a millimeter. Whereas if you're moving it by hand, you know, you're trying to move this entire thing from a single point within like 1/10 of a millimeter, it's going to be not as precise, you know. So that's why I got in the hang of jogging, I think. But I'm going to do my best here to do it without jog. So let's put on translation mode. I kind of preset my angle, so I'm just going to move it down into the joint here. Slow and careful as I can to my weld start position. Yeah. It's like a good weld start position. It's actually just about touching the surface, close enough to be in focus. So I got that set and bam, that's the next position. I'm going to slow that down because I'm going towards that part. I want to be much slower. I'm going to go 100 centimeters a minute. That's kind of my go-to for the close range stuff. That one needs to be a fine position because I need to stop there. I was mentioning I do a little bit of a pause here. I'll drag from my history menu here so you see that I'm only using these ones. I'm going to put the wait command there. Let anything settle. If there's any vibrations going on with the table, I'll just put 1 second. And then I'm going to do my laser on. I'm going to set the fusion lock on, power ramp up delay. I only wanted to sit there for a short amount of time with the fusion welding. It gets the, you know, we're not incorporating a cold wire, so it'll start the weld very nicely, quickly. Maybe a 50 millisecond delay on that power ramp up. I'm also gonna put the weld program setting at the beginning so I can tell it what setting to use. This is 1/8 inch stainless, so I'm gonna use, I don't want to stick it to my table though. So I'm gonna make sure I don't over penetrate. So I'm gonna go to setting A2. A2. I think I'll just leave it as A2 for now. We'll see how it goes. Maybe I'll go up in power a little bit. Yeah, let's just go a little bit more power. So like 850 watts. Okay. All right, so then I'm gonna use translation mode again to get here. What I'm gonna do as I approach this point is I'm gonna start to change the angle. Not extreme, but I'm gonna change the angle a little bit so that when I go around this corner, it's easier. Probably the best thing to do on a sharp corner like this is just make this 2 welds. Because to go around that sharp corner, it's gonna do a really fast motion of the robot. But yeah, I'm gonna try to do it in one. I'm gonna lower the power as I get here. And then I'm gonna have it do like the motion and then raise the power and move along. So we'll try it that way. Translation. Bring it over here. Oh, hold it a little too hard. And then once I get over here, I'm gonna kind of start that rotation there. So I'm gonna put it on rotation. Kind of start that rotation about that point. Back to translation. All right. Let's drag that point. I don't want it to stop there. I need it to continue. So I'm gonna make that continuous. But I'm gonna make it slow down a bit as it gets there. So I'm gonna end up lowering my power somewhere around there. So like continuous 50 there. I won't bother with changing the power. I would need to see what the first weld does before I do anything like that. All right, and then I'm gonna continue moving on to the next point. This time I'll put it in free. There. Yeah, let's go there. Give you a visual of that. Point. Added another point there. Then I'll do my laser off. And I'm gonna adjust my ramp down also of the laser just because I didn't give it enough space there, so it's gonna get a little hot at the end. So I'm gonna change the ramp down to be shorter. Oh wait. One sec. Okay, so I've made some adjustments to the ramping and the power here. So good. All right, so now I'm teaching a point up and away from the clamps before I send it home because I don't want it to hit that, trying to just go straight home. So I'll teach a point here. And then I will copy and paste my home position. Copy, paste, bam. So I have the laser disabled. So what I'm gonna do, because I have this basically on the part while I was teaching it, I'm gonna just remove the tip and verify that, you know, my laser, my guide beam is gonna be hitting the right spot while it's welding. I'll just put this round nozzle on. Okay, and let's run it at a little bit of a slow speed, so make sure I didn't make a mistake. If it crashes, I'd rather have it go slow. All right, then I'm just gonna kind of look at it. Want to make sure, even though it's on dry run, I always have my glasses on, just in case I forgot to click it or something. You want to have your, anytime you're around the laser, you want to have these glasses on. You know what I probably didn't do is adjust my speed on these welds, so it's probably gonna go very fast here. Yep, pretty fast. So I need to
That's what
adjust
we
that.
want to.
That's why a dry run is good. Okay, so I need to change my speed. At some way, there's a way to set your default speed so that like you don't have to think about it every time. But again, when we do stuff different every day, it's kind of doesn't make sense to set defaults. All right, so let's change the weld speed. That was 750 millimeters a second, or is that equivalent to 4,500 centimeters a minute? Yeah, that was fast. All right, so we're gonna go reasonable speed, 70 centimeters a minute. All right, let's do another dry run, kind of take a look at that, see if I need to change anything. I know it's not gonna crash. I'll just go ahead and run it. So you can see this taking a slight curve to the head as it's approaching here because I taught that point at a curve. So it's going to interpolate, you know, that line, but also move to the position I told it. And it's going to get to the end. And then it's going to start moving the robot, you know, the whole time we're maintaining some type of an angle to the surface. I think that's going to work great. So we're just going to go with that. All right, so next thing, turn the laser on. And weld, run. I really hope I didn't put too much power and stick this right down to the table. Has happened before. That looks like it worked beautiful. A little bit hot at the end, but all of that can be adjusted. All right, wow, that looks awesome. You said first try, right?
Yep.
All right, let's see.
Cool.
Sit there. Not bad, huh? All right. All right. Any other requests
That's
or
pretty
questions?
impressive.
Oh, thank you. So you can see the programming, once you become comfortable with it, it can be fairly quick. Um, I was lucky I didn't have to make any changes. That worked pretty well, but, uh, even if you had to make changes, you saw what I did on these ones. It's just changing power, changing speeds, nothing too crazy.
Could you explain how you do the zigzag spot weld? I know that's another way to do it.
Sure. Yeah. So, zigzag spot weld. So the laser beam typically, let's do it this way. Laser beam's wobbling side to side, right? It has the galvanometer inside. So it's going really fast, and as it's welding, it's basically making your weld wide the whole way. So there's a trick you can do with custom settings, taking control over that wobble speed and the width, and you can make it wobble very slow, but you can move pretty fast, so you get this weld that's like a zigzag, right? And it's something that they're doing in like some automotive manufacturing. I've actually seen it in some other places too, but typically it's done with thin sheet metal like you're working with. It might work good for your lap joint configuration, where you can weld through two pieces of metal like a spot weld, but do that zigzag, and you end up you can imagine it like a zigzag weld, right? If your weld is this long, but it's zigzagged, it's actually like this long, but you just kind of crunched it up into this space. So you get a really, really strong weld with a wide footprint without overheating the metal too much. I'll grab a thin piece of metal. Give me a second. I'll grab a thin piece of metal. I'll just kind of set one up real quick. It'll be a really fast demonstration. So give me a second here. Okay, so I have this piece of 16 gauge stainless that I found. So I'm just gonna stick it right down onto here. Let's do this lower ledge here. That'll be a good angle to show you. This. All right, touching pretty good. Okay. So yeah, I'm gonna do that zigzag from here to here, and I'll show you. So I'm just gonna kind of use the program I already made. Oh no, I can't because I moved the part. All right, so let's make another one. Select program. New zigzag. And I'll just do this one without narrating it. I'll show you how to make the setting, but all the positions, I won't go through that again. All right, so I'm gonna show you how to make that setting. Oh, actually, hold on, I got two more things to do. Up and away from the joint. And home. Okay, so I'm gonna zoom in here, show you how to make a zigzag weld. I'm gonna go pretty fast on this. What was the speed that I selected? I did 130. I want to show you that can be done fast. So go to LightWELD interface. I'm gonna once again make my user setting 13. To get through, I'm gonna select my power that I need to get through the 16 gauge and then into the next piece. So, you know, let's say it looked like 800 watts was really good for this piece to this piece, and I didn't over penetrate. So I think I can probably use the same and it'll be just fine for this. So we'll just go, actually, you know what? No, I'm going fast. I need to go more power. Sorry, you're hearing my internal monologue here. So my weld width, I'm gonna go about 4 millimeters wide. I can go up to 5. I want it to wobble side to side. Maybe try like 7 times a second. So based on the travel speed, you'll adjust that wobble speed. I'm just gonna go for 7 times a second. We'll see how it works. Disable wire feeder. Everything else looks pretty good. I think I'm gonna make my ramp down a little bit faster too. All right, so save it. We will go back to the weld program and I'm gonna dry run it. Make sure they're not gonna crash anything. Take off the teaching tip. Reinstall my welding tip. All right, laser off and dry run. All right. So I think you want to see this up close, maybe. I'm not sure how well the camera will pick it up. But let's turn dry run off, weld enable. There you go. Oh, I got the spacing just right. So you can see it's just going back and forth with that laser. Kind of looks like shoelaces. Bam, done. So this can be done incredibly fast. Looks really good. You can see the penetration we're getting. It's just the right amount. It's not discoloring it, but you can see that zigzag pattern in the metal. A little bit too much time at the end there. Again, I need to lower that. Well, I need to start ramping it down before I get to the end is what I need to do. And this is incredibly strong because you have a 4 millimeter footprint for your weld. You know, but it's just constantly moving around. We've done this and done some strength testing. It's incredible. Yeah, so that's the zigzag there.
Mike, is there any reason to think that wouldn't hold water?
Nope.
Yeah, it should hold water just fine.
Well, I mean, with all seriousness, that's what we're doing. Is we're trying to put a bottom in, and it has to not leak out stuff.
Yeah.
So.
Yeah, the only thing you want to make sure is if you're going to do this and it needs to make sure that it feels all the way, is that whatever fixture you have to hold your materials in place needs to make sure that those materials are touching the whole way around. And
Right.
and then that has no problem. And you could even not use the wobble. You could do it a straight line weld, make it super narrow, take all the wobble out of the laser. That's the way to get the ultimate speed. You can travel so fast. I think we did
What was your linear speed on that?
On that?
weld? Yeah.
That was 130 centimeters per minute. I'll show you another one that we did with no wobble at all, and we went quite a bit faster. This weld here was done with no wobble. Is probably max power, right? This is 140 inches a minute,
Oh, wow.
Wow.
and that's full pen on 90 thousandths. This joint was, to get that kind of speed, you don't have any width because you're not wobbling. The laser beam's tiny, right? So
Right.
you have to have your parts, in order to do this, your parts need to be perfect. So, this part, obviously I broke it. It was like tabbed together. The fixture is super tight, holds everything. So for this kind of speed, you got to have things like dialed in your fixturing. But for the speed we were doing there, it's pretty easy to because you have quite a bit of width that we're working with. Yeah, 130 centimeters a minute. So that's not too bad. And based on this, right? So we're wobbling this 7 times per second and going 130 centimeters a minute. And we weren't at max power. We're at 1200 watts. So and you have an XR, so yours is automatically going to get more penetration than what I'm using, which is an XC. I can wobble this up to 300 times a second and just move a lot faster and then crank my power up. So, you could definitely go a lot faster and get the same result here.
Could you touch up your points and do another one right beside that, please?
Yeah, there's no,
Is there any room to?
I can do a small one right next to it.
Okay.
I'll narrow it down a little bit. I just don't have, oh, you know what? I got another piece of metal. I'll just do another one right next to it. You're right.
Sorry about that. I'm at home with 2 sick kids, so I missed part of your first one.
Oh, no problem. No problem. Yeah, I'll just touch up those points. Not a problem. I am currently just finishing with getting sick, so I feel for you there.
Yeah. Can I get you to jump over here to the wooder and help me, clean out this, paint room? We're trying to get stuff on our side of the wall. Yeah, well. You. Stop there.
Fit by there. Okay, so to touch up, I'm gonna just change that teaching tip back on so I can find my focus distance. See, I actually changed planes here because now that I'm doing this one and the part moved a little bit, I actually stacked up 2 pieces of metal here, so it's a little higher than it was before. If it wasn't higher, if it was at the same height, I wouldn't really have to put that teaching tip on. I could just move the robot without going in Z, and then it would keep that focus distance. But because of this, I'm gonna, reteach the height of those 2 points. Okay, so let's see, the points we're gonna need to change are the ones right before laser on and right after laser off. So I'll highlight that one. And then I'm gonna go ahead and move Mr. Robot over there. I may have made this really far away. Oh well. Oh, and I need to do this way. All right, yeah, I moved it a little bit too far away. Put there. Absolutely too close for comfort there. Okay. Touch up. Also gonna touch up the point above that. Touch up the point at the end here. Okay. And let's see, what else can we do? Maybe we could try to go a little, it worked really well. So I'm just gonna leave it the same. I'm gonna say we can try to go faster, but it was perfect, so.
Were you gonna change the ramp down or something at the end, or?
Yeah, yeah, I'll do less time on the ramp down. Do that. All right, so are you guys ready? You got a view this time?
Yep.
Okay. I'm gonna dry run it once, make sure we don't crash. I think we'll be all right. All right, and I will go ahead and weld.
That's pretty sweet.
Try to get it in the light so you could see the zipper on the back side of the. It's not cooperating. I saw it. Anyways, you can kind of see the little bit of movement there on the back in that shape. And yeah, if we want a little bit more penetration, just turn the power up. But that's plenty strong right there. All right. Any questions, you guys?
No, I don't think I have any more. Bob, you got anything?
Nope.
Enrique, we snuck you in on the call. You got any questions?
I think I'm all good. I appreciate it, guys. Thank you for your time.
No problem.
Yeah, thanks a lot. This was really educational. Very good. Thank you.
You're welcome.
Appreciate it. Thank you.
No problem. Hey, did you guys want us to send you this part so you can take a look at it?
Sure.
All right. Glenn, do you have their address information, stuff like
Yeah,
that?
I'll get it and we'll send it off.
Okay. Awesome. And we'll get this video sent over to you as well in case you want to show somebody else.
Oh, awesome. Will do.
All right. Have a good one, guys.
You have a
Thank
good
you, guys. Appreciate
Thank
it.
you. Yep.
No problem. Thank you.
Thank you.